Hey everyone, so here we have a question from thermodynamics. It's a PYQ from JEE Advanced 2022 paper 1. So the question goes like this. Alright, it's a very simple question. List 1 describes thermodynamical process in 4 different systems. List 2 gives the magnitude, speed, the exactly or a close approximation of possible changes in internal energy of the system to the process. So let's see here. Let's check at this one. It is given that the mass is this water at 100 degrees Celsius converted to steam, okay, at same temperature at a pressure of 10 to the power 5 pascals. The volume of the system changes from 10 to the power minus 10 to the minus 3 meter cube in the process, the radiated water. So entire mass of the water has changed. Okay, fine. So what is the work done? Work done is equals to P delta V, isn't it? And the temperature is constant, the pressure is also constant because it's an open vessel. Okay, it's being heated and steam is gone. So it's an open vessel. So what is delta V? It is basically 10 to the power 5, okay, into 10 to the power minus 6. Okay, final minus 3 minus 10 to the power minus 6. Now we'll neglect this guy because it's very small. Okay, so we'll write this as 10 100. Let's 100 joules. Alright, and what is delta Q? It would be m into latent heat of vaporization, and that is 10 power minus 3 into 2250 kilojoules, so 10 cube joules. So we got this. Now delta Q is equal to work done plus delta U. That is the second law of thermodynamics, right? So delta U is equal to delta Q minus W. So that is 2250 minus 100, which comes out to be 2150 joules, which is around 2 kilojoules. So we can say first one option is B. So you have already got the answer as option C. Okay, we will go further. Fine. Here we have 0.2 moles of rigid diatomic ideal gas, diatomic ideal gas, alright, with volume V at temperature 500 undergoes an isobaric expansion to volume 3V. Assume R is equals to 8. Okay, it is gone under isobaric expansion. Fine. What we will do here, we can do this, right? NCP delta T here, right? That is the change in internal energy. That is delta Q. Change in internal energy will be NCP delta T, right? Okay, fine. We'll just see this. It's 500 Kelvin, right? We know initial volume, we know final volume, we know pressure is constant, we know number of moles is constant. So that means we can use this relation, right? So V by 3V is equals to 500 by T. Okay, so T is equals to 1500. Okay, so delta T is basically 1000. And what is the delta U for this then? It is NCV delta T, which is 0.2, and CV for diatomic gas is 5 by 2 into 1000. $500 joules, isn't it? Oh, it's not. Okay, yeah, 500 into 8, right? We forgot R here, no? So this is basically 4 kilojoules. Okay, so yeah, 2 option R. Don't forget R, okay? So I'll rewrite this. Okay. I'll explain it again for better understanding. We used, it's an isobaric process, so V is directly proportional to T, we know that, and we got T as 1500, so delta T is basically 1500 minus 500, that is 1000. We got that. Now NCV delta T is basically 0.2 into 5 by 2 into 8 into 1000. Okay, so this comes out to be 4 kilojoules. This one. Okay. R. Now next we have 1 mole of a monatomic ideal gas is compressed adiabatically from volume V is equals to 1 by 3 and do V by 8, so that is just 1 by 24. Okay. Okay, for this it's actually the monatomics means it's basically degree of freedom. Delta U is basically degree of freedom by 2 into P2 V2 minus P1 V1. Okay, we can calculate the pressure through the adiabatic law, you know, which is PV to the power gamma is constant, you know, and gamma here would be 5 by 3. For monatomic it's 5 by 3. Okay, so we'll do that over here. Okay, so what is initial pressure? Initial pressure is 2 kilopascals, 2000, and volume was, say volume was V to the power gamma, and it got converted to some pressure in final to V to the power gamma by A to the power gamma. So pressure is now 2000 into A to the power 5 by 3. So I don't know what, see, okay, it is basically 2000 into 2 to the power 5, which is 2000 into 32, which is 64 into 10 to the power 3. Okay. Okay, so delta U is equals to 3 by 2. P1 was 2000, right? 2000 into 1 by 3 minus 64,000 into 1 by 3 into 8. This goes 8,000. So this is 6,000 by 3 into 3 by 2. Okay, it's actually P2 V2 minus, I've done P1 V1 minus P2 V2, so I have to write negative over here. This goes 3000, so the answer is 3 kilojoules. Okay, which is option number T. Did I get it right? Yes. 3 is T. Now fourth one, it undergoes isobaric expansion. Fine. 3 moles of dynamic gaseous molecules can vibrate. Is given 9 kilojoules of heat and undergoes isobaric expansion. Okay. Okay, so heat is 9 kilojoules, which is basically NCP delta T. From here we can get the value of delta T, and once we've gotten the value of delta T, we can just calculate we can calculate NCP delta T. How do I know it's a CP? Because it's an isobaric process. Okay, so this implies 9 kilojoules is equals to 9 by 2 R into delta T into 3. Okay, this gets cancelled, so 2 by 3 R kilojoules, that is your delta T. Now what is NCV delta T? Delta U, that would be 3 into CV, which is 7 by 2 into delta T, which is 2 by 3 R kilojoules. So now it won't be kilojoules, it just be into 10 to the power. Delta T we can't write it kilojoules, right? Okay, and here also R. So this gets cancelled, this gets cancelled, this gets cancelled. We get 7 kilojoules. It's option Q. Yes. So we got all of them right. Thank Thank you.